Hello, I'm Robbie Clark. Welcome to my workshop. I'm going to start another project, again almost exclusively on the milling machine, but the item I'm making is actually for the milling machine. It's actually for the milling machine vise. This particular item, I'm sure it has a name. I've got no idea what that is because I've seen these in use on YouTube channels, and I try to look back to find who made them to get some sort of ideas basically before I start making it, although I think the design of this is very simple anyway, but I've had no luck so far. So if you know what this thing is called, if it actually has a name, let me know in the comments. But I've made an extremely rough drawing of this. You've got to use your imagination here, but this basically is what it will look like. It will be two pieces of material. I'm going to make this actually out of aluminium. So these will be sort of parallel sides to one another, and it has a bar going through the centre here, and this formed a swivel. So I'll start by bringing a piece of material to size and then cutting it through the centre. I'll then pick up the centre and drill a hole all the way through, and then individually each side will have a taper cut on it on each side, on both pieces. And the idea of this is that this could be used in the milling machine vise if you're machining a piece of material which isn't actually square. If it was tapered, it would be quite difficult to hold in the vise. So the idea is that this side would butt up to the moving jaw, and this side would go between the material and the fixed jaw, which would be out here, and this part, depending which way round you put it in, that part would swivel to lock on to the piece of material. I don't think it's going to be sort of a difficult thing to make. These bits will be quite easy to machine. I just need to sort of work out an ideal angle for these parts here. The spindle that will go through the middle, I'm going to make it so that it has a flange on each side, so that when it's mounted between these two pieces, it will hold in place, and this part won't move. It will be captive on each side. The piece of material I'm going to use, it's a piece off this bar. I've already cut a piece off, and when I machine it, it's going to end up around about 1.25 by 3/4, and I'm going to make it about 3 inches long. The vise I have on the milling machine is, the jaw width is about 3¼ inches, so 3 inches wide will be fine. So we'll start the video off. I'll just show you briefly some things of bringing the piece of material to size. I'm going to fly cut all the sides here, and then just face off the ends, just to clean it up basically. I mean the measurements haven't got to be absolutely precise, just near enough will do, because I can easily work out the centre here, because this part will obviously be cut through the middle here to make the two sides, and then I can clean up these sides together and then clamp. I'm hoping I'll be able to clamp these in the milling machine vise, pick up the centre, and then drill through an appropriate size for the rod to go through the two sides. So I hope you'll find this interesting, and sort of come along with me on the adventure of making this. Well, let's see how we get on. job now is to machine both of these pieces to size. Size isn't actually critical, it's basically just to clean the surfaces up. To get these in the vise, I've put parallels below here, and I've set the parallels diagonally across so that I support part of one edge of each and support the centre between the two pieces to keep them level. So it's the same on the other side. I checked the pieces. I actually sawed these in half using my bands, so I had to be a bit creative to get these in the bandsaw to cut them in half. I clamped the two, or the one piece at the time, to another piece of flat metal, and then clamped that piece in the vise on the bandsaw, and I've succeeded in cutting them in half. It's not it's done a sort of a reasonable job, but checking them, I've got the low spot is here, so I've got to obviously bring the two parts down to sort of clean up to this height here. So what I'm going to do is clean it up as best as I can, and then when I've got it sort of level all across, I'll make a final cut with a fly cutter to give me a sort of a decent finish. I won't show all of this because it's obviously going to take me quite a while to do this, but I'll start off and then I'll bring you back when I'm sort of nearer to finish. there's quite a lot to come off there. I'm using a roughing end mill to do this, and I'll make another light pass just to get me closer to this corner height here. That sort of worked okay. Once I'm sort of near to this, then I can use a fly cut on it, but I'll bring you back for that part of it. That was quite a lot for my tiny little mill to cope with there, but it seems to have done it okay. Even though I quite like the effect that end mills give, they give a nice swirling pattern and overall quite a nice finish. I'm still going to fly cut this so that the surface here matches all the other surfaces. So I'll bring the tip of this fly cut has got a little carbide tip. If I bring that down and until that touches, then I can make a cut. That's it. That's touching the surface, so we can wind that off, and we'll put a cut on. See if this pass will actually clean up or not. Bit of a WD-40 on there. Spread it around a bit. Okay. Well, that's good. It's cleaned up quite nicely, so I won't need to make any more passes with that. And the fly cutter always gives you a nice finish. I'm quite pleased with that. So I've just got to remove these parts now. Do a bit sort of clean up all round, and the next job will be marking the centre. Obviously here you can see the centre where the two parts join. Not quite sure whether they're going to go as they are or whether they will be face to face, but I'll have a look and see what the best way round is with this, and obviously setting the length, and then I've got to work out what size hole to drill through the centre here. Well, the two halves have come out pretty nice, very pleased. Just going to decide what size hole to cut through the centre here. I think I've decided to do it 1/2 inch. I think the 1/2 inch will work out fine, so I can drill for 1/2 inch reamer through the centre here. I think a 1/2 inch ream is the largest one I've got anyway, so that will hopefully make sort of a nice swivel point in the centre of this. And of course, once the hole's cut, I can then sort of mark out the angles across here, so that gives me the sort of swivel point. So I would later have to sort of machine out all these sort of wedge shapes all the way around. Now, once I've drilled this through, I think there's two ways of putting a shaft through the centre here. I guess one is using something like this. This is silver steel, or drill rod for Americans. What I could do is just cut this to the exact width here, and then make some little end caps and attach the end caps on either side. The other option is, if I can find a piece of material obviously larger in diameter than 1/2 inch, and then machining a section out of the centre here to drop into what will be the sort of half hole size there. So that would drop in. I'll have to decide a bit later on how I'm going to do that. Now, drilling the hole through here, obviously I've got to do this very, very accurately. I can't do it on the milling machine because, as the milling machine is so small, I've got a limited amount of Z height to be able to get a drill in. I could probably just about do it, but I wouldn't be able to get the reamer in as well. I mean, I have tried this on other projects in the past and it just doesn't work. So what I'm going to do, I'm going to set up the 4-jaw chuck on the Myford lathe, and then obviously once I've marked the centre here, I can adjust the 4-jaw chuck to give me a perfect centre on this position here, and then I can drill through, and that's not going to be any problem at all on the Myford lathe. I've drilled and reamed holes that size and even bigger holes than that on the Myford lathe in the past, so I don't think that'll be a problem. So I'll set this up very accurately, mark the centre, and then bring you back when I've got the lathe all set up to actually drill and ream the hole. Well, I've set the workpiece up in my 4-jaw chuck, and I've put little copper shims all round to try and protect it, and you can see I've got a live centre here and a dead centre joining the centre here and the punch mark in the workpiece here, and I've got my clock gauge against it, and then I've messed around for ages trying to clock this in as near as I can possibly get it, and about as close as I've managed to get it is within a thousandths, which I think is going to be okay. I didn't show any of this because for me this is quite a slow process to do this. I've set work up like this before, and it always seems to take me ages to clock this in, and I'm certainly not as fast at doing this as A-Bomb is on his channel. But anyway, I've got this all set up now, so I can break all this down and then start drilling through. So I'm going to centre drill and then use a number of drills to bring me up to size. And as I mentioned, I'm going to drill this so I can ream it to a 1/2 inch. So I'll end up with well, the nearest I can do it I think is an 11.5mm drill, which will give me a reasonable drill size for the 1/2 inch reamer. So bear with me while I break all this down and I'll get the drill chuck mounted in, ready to start doing this. Well, I've centre drilled this already, and I started off with a 5mm drill, and I'm just going to go up through the drill sizes to drill the hole through till I get up to the 11.5mm drill. It's not the most interesting thing to watch, but there we are. So let's drill, and we have here this is a 9.5mm. So I'm just gradually going to build up through the various drill sizes. This is the final drill size now. Cutting fluid on it. Okay, so next thing is to get it set up for the reamer. I'll bring you back for that. Obviously with the reamer I've got to slow the lathe right down to its sort of lowest speed, so that you get a decent reamed hole. I've already set that, so you see the lathe is running a lot slower now. Put plenty of oil on the reamer. Reamed right through now. I'll run that out. It looks okay, so I hope I've got a nice it feels a nice smooth hole through there, so hopefully that's going to be fine. So now I've got to sort of break all this down, and next stage will be obviously I'll deburr around the outside here. We'll be marking out the angles and machining those, so moving on quite nicely. This was I think sort of one part of the job that worried me the most, was drilling this hole and reaming the hole, having sort of clamping the two parts together in here and getting them in so that nothing moved, I put these bits in the 4-jaw chuck and kept tapping them back against the against these jaws. I had these jaws reversed to make sure it was held in sort of nice and square, but so far all seems to have gone okay. But anyway, I'll bring you back when we get to sort of the next stage along. Well, just a recap on where I am at the moment. So you saw me drill and ream the hole through the centre here. I mean, the reamed bit came out really nice actually. Very pleased. So those parts line up beautifully. So as I mentioned, the next job will be working out what angle I need to machine the sides here. Obviously the angle is going to be, I guess, from about here out to here, so I'll roughly work some positions out and then use my angle setup blocks to work out the ideal angle to machine those out. That's obviously going to be quite a long job because I've got 4 of them to do, but that is the last job on this particular part. The next part along from there obviously is making a shaft to go through the centre that these bits will swivel on. You see I've got laid out on the bench all the bits and pieces I used, my bits to clock the part in, and what I like to do is lay all the drills out ready, sort of try and work out in advance exactly what I'm doing, so with the centre drill and the various drills to step up to the drill size for reaming the part out. If it is of interest, that's the cutting solution I used, molly slip. I don't use this all the time. The nice thing about this particular one is that it's a fairly thick oil, and it sort of stays on the drill. A lot of cutting oils are so thin that you put it on and most of it runs off, but with that one being slightly more glutinous, it stays on and stays with the drill while you're drilling through. But anyway, that's where I am at the moment. So I'll bring you back when I've worked out the angles, and I can then mark this out and then perhaps just show a bit of machining, perhaps just of one of the angles, but obviously I'll bring you back for that. Well, the next job's going to be to machine a spindle, I suppose we'll call it, to go through the centre here. As you saw, I'd drilled and reamed this the 1/2 inch. This is a piece of 1/2 inch silver steel which fits very snugly into position, and the two sides meet perfectly, and that's sort of quite a nice fit. So I'm hoping I can get the spindle as good a fit as this. I'm going to machine a piece on the lathe and machine it so that I've got a flange on sort of each side of this to hold it in position, and I'm using a piece of roughly 3/4 of an inch round stock. I decided that it's best to machine the spindle first before I cut the angles on here, because if I'd have cut the angles first, I lose the perfect round shape here. So it's best to do this first so that I've got these two halves to make a sort of a final test fit on the part. I'll just swing the camera around so you can see the bit of material in the lathe and how I hope to do this. I've got the bit of stock mounted in the chuck here. I've already faced off the end and centre drilled the end here, and I've got a live centre in here to support that end, while I've just sort of cleaned up the outside diameter here. So what I'm planning on doing is just machining out you see the two marks here. That's the width of the part, which is 3/4 of an inch. So I'm going to machine that out down to the 1/2 inch, and then this will be a sort of a flange on each side, hopefully. I'm going to sort of plunge cut this. I think I'm going to try and do it with a parting tool and see how I get on, sort of machining that section out and make some very, very light cuts until I get it down to size. Obviously I've got to take a lot of care in doing this, although obviously if I make a mess of it, I've got another bit here I can use. But this is mild still. I think it might be EN1A, I'm not absolutely sure, but it is actually machining very nicely. I'm getting quite a nice finish with it, so hopefully this is going to work out. I don't think I'm going to sort of film much of this because I've got to get in obviously to quite close in to do this, and it's going to take me quite a long time because I'm going to take this very, very slowly. But perhaps I'll bring you back when I'm sort of near to doing a sort of a test fit on it, and see how I get on with it. So I'll been hopefully sort of bring you back a little bit later on this piece. Well, I've machined it down to size here. It did take me rather a long time to do this. I wanted to get it as accurate as I possibly could. I used a variety of lathe tools to do this, and when I did try to do it with a parting off tool, but that didn't work. So what I did in the end was I machined quite a bit of it away using one of these button tools. Got a lot of it machined out just in the centre part here. But then obviously the easiest way from there was to use left and right-handed tools to machine the rest of this out, and then bring it to length to get these ends nice and square. So when I was almost right down to the right dimension here, I used this tiny parting off tool, this one. This one seemed to be a lot better than the larger one, and then just literally just plunged that in and ran it from side to side, literally taking a couple of thousandths off at a time and then miking it up until I'd reached the right diameter, and then obviously then I could make a test fit with the actual parts, which fit in here really nicely. They fit in quite tightly, and I've got a perfect sort of alignment on both sides, and it's going to sort of, I think sort of swivel quite nicely like that. So I think that's going to be fine. So all I need to do now is obviously break all the edges, put a chamfer on all these edges, and then I've got to part this side off to this same thickness here on that side, and then that part really is finished. Then obviously I can move on to the next bit of cutting the angles on the two sides then. So I'll part this off and then bring you back when I've sort of marked out the parts to cut the angles on them. Well, my next job was deciding what angle to machine these parts out to here. Obviously it's got to be an angle machined across here on both parts, so it's 4 angles I've got to machine. I think I've decided on a 10-degree angle, and the way I sort of checked this out was I put the spindle in here. You see the two parts fit very nicely together. I've got a very, very good joint, and it's all very sort of firm and tight as well, which is good. I've put a little mark here, sort of level with this edge, and I've actually used this mat here to work an angle out. So if I put the block on there and then line it up, this is obviously a very crude way of doing it, but it sort of worked. Just line it up and then hold that part down and then just push the angle block in so that I line up the angle block with another line, and I think that's going to give me a good enough angle. If I line that across there, that's obviously, that side is the part that's got to be machined out, so the machining will be to a sort of about half the thickness of this. So all I'm going to do is work out where the line comes to here, and then I'll go around all the parts and put a mark across here on all four sides, and that will be my datum to machine down to, across here down to that position. So I'm not going to bother sort of mark everything out, just the line here will be sufficient really, and I think that angle is going to give the tool enough for sort of, well, I hope most applications anyway, so I hope that's going to work out okay. I'm just going to break away from this project for a moment to show you a sticker that arrived in the post for me this morning. This is come from the US, from San Jose, and it's the Air Cave Shop. Dean, it's his channel. It's a very, very interesting channel. Dean is a retired gentleman like myself, and his workshop, he says, is in a two-car garage, and he does all sorts of really interesting projects around the workshop. He's got some very, very nice machinery in the workshop as well. One bit I've really enjoyed recently, he's got this really nice shaper. There's a picture of a shaper here, and obviously a milling machine, literally just showing the shaper bringing a block of steel to size. I don't know what it is about shapers. I really love seeing them work. I find it sort of quite a calming, peaceful thing to watch, actually. It's a machine. I would really love to own something like this, but my workshop is far too small to have a machine of this sort of size. I'd need a workshop double the size of mine. I mean, my workshop is only about 8 foot wide by, I think, about 12-13 foot long, so I've not got the room for anything like this. But he does all sorts of other interesting things, working on his lathe, sort of regrinding the surface of the headstock of the machine to take the chuck, and all sorts of, lots of other interesting things around the shop. I would highly recommend you take a look at Dean's YouTube channel. I think you'll be actually fascinated by the stuff he does. He's I think history is he is actually an engineer, so obviously he's got a lot of expertise in everything he does. So give him a look. I hope you'll enjoy his workshop. Obviously it's the Air Cave Shop. I'll put a link obviously in the description down below my video, but I'll just swing the camera around and we'll put the Air Cave Shop sticker up on my wall. Bear with me just a moment. Here we are, back to my sticker panel. I'm going to put you in here, Dean. I think they should fit nicely. Try and get you on nice and straight. There we go. They're reasonably straight. Get your lozenge shaped sticker on the wall. Lovely. Thanks for sending that to me, Dean. It's very, very nice. And it arrived so quickly from the US as well. Obviously got a slightly better postal service than we've got here in the UK. So I hope this picks up more subscribers to your channel. And I'll obviously look out for more shaper work from you as well. Thanks very much, Dean. Cheers. I've got the part set up in the mill vise now in the sort of usual method of using an angle setup block, just to give the block a little bit more height. I've used a small parallel. Using it that way, even this small one, the smallest one I've got, was too tall, so I've used it flat. Now, I've noticed a number of people that have said that it can be a problem using parallels or flat like this, because they are machined very accurately this way, which obviously they have to be, but they may not be the same thickness all the way down here. So what I've actually done with this one, I've mic'd it up just to make sure it is the same thickness all the way down, which fortunately it is. So that can go in the bottom of the mill vise first, and then the parallel was on top, and I've set this part and gently tapped it down against the angle setup block, so that's set the angle really nicely, and I've locked the vise very, very tightly in position, because once I start cutting this, obviously there's no support for the part in the vise itself, so make sure that I've got that locked really tightly, and I can remove the angle setup block. I've got a 12mm cutter in here. You can just about see that it's a brand new one. It's a Dormer cutter. It's never been used before. This is one of a number of cutters that were gifted to my workshop a little while ago, so I'm hoping this is going to produce a sort of a nice finish for me. So I'll get this sort of set up and in motion, and bring you back for sort of bits of the cutting of this. I won't show all of this because there's quite a lot to machine away here, and I've got 4 of them to do, so I'll obviously only show a bit of just cutting the first one. Okay, so we'll touch off and then start. I'll put a cut on and we'll start the milling process. It's a nice sharp cutter, so I hope this is going to make fairly short work of doing this. So I'll carry on and bring you back when I'm virtually down to the line here. Okay, final pass. that's it. First one of 4. Quite a nice finish. It's nice and sharp, that new cutter there. So I'll do the final 4 of these, and then we'll be basically completed, apart from sort of a bit of a clean up. Then we'll have a look at the finished part then. Well, that's the project completed. I'm quite pleased with how it's come out. Machining the angles here was the last job on the 4 pieces, and that worked very well indeed. So you can see I've got a good swivel joint on those now. I'm sure that will cover all the angles, hopefully, that I'm likely to require in the future. And the cutter I used worked really well. It was obviously a quality cutter, that, so not a mark on it actually. And obviously I couldn't have done the job without my set of angle setup blocks. In the past, before I had this set, I had to make my own angle setup blocks, made of scrap bits of metal or bits of plastic, which sort of did work quite well. But now I've got this set, it's obviously much easier to do it now. A bit of an apology actually, while I was machining the angle you saw me doing, the x-axis on the mill was making a terrible, like, sort of scratching or squeaking noise. I wasn't quite sure what it was, when I thought that it was a noise from the winding handle that was making that noise. And I did try dropping some lubrication sort of, if you like, behind the handle itself, but that didn't cure it. So off camera, while I was before I started machining the other 3 angles, I took the handles off, and what it was is the bearings at each end of the lead screw on the x-axis, I think, were very dry. So I pulled them out and gave them a bit of a clean up, and then re-lubricated them and put them all back together again, and it seems now to have cured the problem. So hopefully I won't have that terrible noise on the milling machine in the future. I'm going to swing the camera over to the milling machine now and show you what this does, how it works. I'm sure a lot of you are familiar with this device anyway. I'm sure you, like me, have seen them before. But anyway, let's go to the milling machine and set something up with them. Right, we're at the milling machine. If you had a piece of metal, an odd shaped piece of metal to machine, like this, it would be normally sort of quite difficult to clamp into the vise. There obviously are other methods of doing this that have been shown by various people on YouTube. One is using a large ball bearing that has a flat on it, so the flat can go against the moving jaw, so the flat doesn't damage the jaw itself, because the ball bearings are hardened steel as well, and the other side of the ball bearing would press against the part and hold it in position. So you've got a good sort of 2-point clamping system. You could also use a piece of round material dropped into here, also with a flat on it, so that the flat would be against the moving jaw, and that would hold the material in position. But this device does, I guess, a similar job, but gives you a good bearing surface, and there's nothing here to damage the material. I mean, the ball bearing could put an indentation onto soft material like brass or aluminium. So with that piece in position, you can then bring in your block here. That would drop down. Just a little bit more. That would go down behind the piece of material, and then that can be drawn across and clamp the piece of material in position. I hope you can see that okay. Actually, if I move the camera around slightly so you can see how it's actually clamping the material into position. Around by hand, so there you see it's got the material sort of firmly held along that edge there. So I think this is going to be if I can get this actually to come into focus. Yep. So it would then sort of hold the material quite nicely into position. Let's put the camera back on its tripod. So quite pleased with the end result of this. I wanted to sort of show it being used, but you know, I searched around all the bits of scrap material I've got, and you know, I couldn't find anything with an angle on it. So I just found this just a little bit of scrap, and I actually machined it to give me an angle so that I could show you how it works. But there you go. So I hope you enjoyed that. I mean, I just thoroughly enjoyed making this. It was quite an interesting thing to build, machining the little cotton reel spindle in the centre as well. I showed this to my wife and she said, oh, it looks a bit like a clothes peg. I suppose it does, isn't it? But anyway, so there we are. That's the end of that little project. So thanks for joining me in the workshop again today. This project, I did make it over a few days, you know, just spending a few hours a day in the workshop as I normally do. Again, also thanks very much to all the subscribers to the channel and all the nice comments I'm receiving, and nice to make contact with a few other members of YouTube and do this exchange of stickers with them. That's been sort of really nice to do, and also with YouTubers in other countries as well, which is really nice. You know, I've had exchanges with a couple of people in America and in Australia as well, which is really wonderful. So anyway, thanks again for joining me. I'm going to try and find another interesting project for my channel, and I'll see you again very soon. Bye for now.